Okay, this is lecture 2, part 3. You see, spherical coordinates, 3-dimensional. Now I want to express this position vector, okay, in terms of r, theta, and phi. Okay? R is the radius direction, in the radius direction. Theta is in this case, azimuthal direction. And phi is the polar direction. Okay? Now, you see, this is just geometry. Okay? I put 3D geometry. Okay? This figure over here. What I want the coordinates, okay? I want to express the Cartesian coordinates that is x1, x2, x3 in terms of r, theta, and phi. That's what I want. Okay? So this is, I repeat, just this 3D geometry. It's quite easy. Okay? Now, you can see clearly on this figure that PQ is the x3 coordinate, PQ. You see, you look at the figure, PQ is x3. So the x3 coordinate, okay, is just OP, okay, which are, okay. Now OP cosine of phi, okay, because this is pi over 2. So PQ is just R cosine of phi, okay. This is right angle triangle, okay. Now, then I already determined x3. Now, x1 is rho cosine theta. So, x1 is just rho cosine of theta. You just look, rho OQ, x1 is the projection, okay, of UQ, U2, UQ over this x1 axis, just clearly. So I'll call this rho. Okay? It's written here, rho. But x2 is just rho sine of theta. You see, this over here, okay, the x2 is just rho sine of theta because this is theta and this is also theta. That's easy. You see? But rho is equal. Now, you see, by the way, rho and theta are the cylindrical coordinates because, do you remember I used the word is on the floor, okay? This is the same, okay? So, I must have the value of rho, okay, in terms of r, theta, and phi. See? It's quite easy. So, you can see here easily that rho is equal. Look this triangle over here. This is a triangle, right? You see? Right angle triangle. So this is rho. It will be r sine of phi. You see? Rho, you see phi over here is opposite to rho. Okay? And this will be R. The OP is hypotenuse. Is R sine phi. So that's it. Then, thus, x1 is equal. I substitute rho here. Will be R sine 5. In this case, okay, cosine of theta. You just substitute rho here, okay, just over here. You see? I'll put a color for you just to see clearly. This is rho. This is rho. Then x2 will be R sine 5 sine of theta. So then I obtained x1, x2, and x3. Now, since R is invariant, look, I write R is equal x1 E1 plus x2 E2 plus x3 E3 is equal. Now, I will have here, I substitute, okay, x1 just from this is x1, and this is x2. Okay. Now, you just just substitute rho over here, and I copy from there. So then I have R sine 5 cosine theta U1 plus R sine 5 sine theta E2 plus R cosine phi E3. Just easy. See? This here, this over here is the component x1. This one is x2. And this over here is x3. So it's invariant. I can write, you see, just substituting there. That's the objective, okay, of this position vector in terms of r, theta, and phi. Okay? That's it.